Welcome to Embedded FM. I'm Elecia White, here with Christopher White. We're going to be speaking with Fran Blanche on music and business.
Hello, Fran. Thanks for being on the show today.
Hey, how are you doing?
Doing okay.
Could you tell us a bit about yourself?
Oh, well, I've got a YouTube channel, and I do science-related vlogs and music-related vlogs and projects and whatnot. And I have a company, Frantone Electronics, where I've been making effects pedals for 21 years or so. And I'm also known in the fashion world as a designer and an avid sewer. So I keep myself very busy on many fronts.
Fair enough. I wanted to ask about the Frantone guitar and effects pedals.
Sure.
When I talk to my guitar playing brother-in-law, he is pretty rabid about what a guitar pedal should do. And there are all these terms, and I have no idea what they mean. Things like warmth and brightness and fuzz, and I see these same pages on your website. Right. What do they mean?
That's sort of a subjective answer. They can mean many things. Sometimes the nomenclature that we use for effects designs, they're sometimes just entertaining or arbitrary. You know, like my fluff knob on the cream puff, for example. But sometimes they're descriptive about a certain function that you're going to control. It's sort of a mixed bag. There's no real right answer for what the description of the control means, but it will vary between what the effects designer is trying to do, either being like direct and technical, or being maybe a kind of whimsical or obtuse, in an entertaining way. It really depends. There's no like firm answer, because the effects pedals they're sort of a very broad kind of product. There's so many different manufacturers, and some effects are technical and direct, and some are sort of entertaining and so the descriptions on the controls might not necessarily mean anything, if that makes sense.
Well, they are call-outs to things that musicians are used to hearing.
Some, yes.
Things like warmth, or they have at least a broad understanding. People usually who do music.
Depending on the pedal, they can be descriptive for tone or certain settings on an overdrive or a chorus or a vibrato, anything. My pedals, I tend to try to, with few exceptions, label the control to say exactly what it is: tone control, sustain, compressor, whatever the control is controlling. But like you say, sometimes with some makers, there are some expectations that a certain kind of pedal should have a certain kind of control on it. And so perhaps it would be labeled to some sort of expectation, I imagine.
So arbitrary. That was the part I got. It really is arbitrary, isn't it?
Well, not exactly.
No. And I remember Matthew having pretty good discussions about what each thing was. But I always wanted to put it back into terms I sort of understood, like what kind of distortion are you adding to the signal? I mean, are you adding it? Are you multiplying it by some other function? What does this look like on a scope?
Well, maybe we should pick one particular effect to talk about in that terms. Because a compressor is going to look a lot different from a distortion pedal.
Yeah, true. There's generally, as a product, effects pedals, this is just my personal philosophy. The effects pedals, at least the ones that I offer, are engineered to be as simple as possible to operate. I used to have a strict 3-knob policy, which I actually ended up breaking. But in a nutshell, it was that any effect should not exceed 3 individual controls. that it should be simplified to the point where anyone can set the pedal to any combination of settings and it'll sound good. That was my basic design philosophy. So in engineering that kind of simplification for the user, you're taking out the technical stuff, so that things like what exactly is the waveform, what exactly is this control doing. These are things that you're not introducing to the customer because they don't want to know. That they just want it to sound good, and they want to know that anywhere you set the combination of knobs, that it's going to have a good sound. But as far as what is actually happening in the pedal, that depends entirely on the design. The effects are, sort of divided into basic categories. There are categories of effects. There are distortion effects, which usually involve some sort of clipping or rectifying, where you're crunching, you're breaking the signal up, clipping it in some fashion. There are subgenre of that is overdrives, which can have distortion in them, but the basic idea of an overdrive is it's a loud, sort of a preamplifier that's used to overdrive or distort an amplifier by just pumping a heavier signal into it. The amplifier actually does the clipping. That's an overdrive. But that's one type of effect. Another is time domain effects, which are your choruses, flangers, echoes, delays. These are all based on time domain effects, where you're taking a copy of the signal either in an analog way or in a digital way, and you're just playing with the time between the original signal and another signal, and the reproduction of the signal. So by adjusting the amount of delay that you're talking about, it will either be it'll either be a chorus or a flanger or a delay. So those are time domain effects, and then there are also phasers.
What's a flanger?
Flanger? Well, it's flangers are effects that emulate the old original engineering trick of flanging, which comes from the 1950s, and when they started doing Les Paul invented. He's given the credit for inventing overdubbing, which is where you take a recording, you record something on a tape, and then you play back that tape and then play something live again and take both of those things and put it onto another tape, and you combine the two. That's you've overdubbed the two tracks. And so when engineers started to do this, these sort of tape things where they record something on tape and then they want to add something to it, at some point an engineer recorded 2 tracks on 2 machines and played them and synchronized them together, and we're playing them back in sync, and then they must have gotten a little out of sync, and as the tapes sort of got out of synchronization, this strange effect happened, and with the stretching of this weird sound, this whooshing sound. And they found that they could make this happen by synchronizing 2 recorders and then taking one of the recorders and putting their hand on the flange of the reel and slowing it down slightly and controlling this sort of weird spacey effect. And it became known as flanging. And flanger effects do the same thing in a solid state way without the tape.
So this sounds like it's constructive and destructive interference, both depending on how much you do it. So it's 2 identical signals shifted a little bit, and that would either increase the signal if it's constructive and on the same wavelength for this particular part of the sound, or destructive.
Right. Well, it's what makes flanging is that there's a dynamic gradual change in the phase shift. So you have 2 signals that are in phase and in sync, and as you slowly delay one of them and slowly change the delay, they slowly come out of phase, and as they do, that sort of slow dynamic way of changing the phase creates this kind of spacey effect sound. So So yes, it is, and what kind of makes flanging work is it goes out of phase and then back into phase and then past. It's kind of going behind and then past and then forward, and creates this watery, wishy, spacey sound that is flanging.
Yeah, I can think of a couple examples of where it's been used on drums, and I think there's a Yes song, and then I'm thinking of maybe that Phil Collins in Here Tonight song.
The original, the first example that I know of in a recording is a song called "The Big Hurt," and I wish I could remember who sang that song, but it was the first one that I know of where it was used. Although I'm sure that flanging was probably accidentally discovered even earlier than that. But yeah, at some point when Bucket Brigade chips started coming out in the early 70s. All these time domain effects where people have been doing studio tricks with tapes, doing like chorus, flanging, things like that used to be done with just using two tapes that were sort of slightly out of phase. And also analog delays just started to explode when Bucket Brigade chips became available.
Bucket Brigade is a term, or was that a brand, or is that
it's a type.
It's a type, okay.
Yeah, it's Bucket Brigade chips. They're used for analog delay, but essentially they're these long chains. Shorter ones have hundreds of stages, like ones for chorus would have maybe hundreds of stages. Ones for like echo and reverb would have thousands of stages. But essentially, it's a way of holding, you have all these little stages that are holding a voltage that are resettable. So it's a Bucket Brigade, meaning that like a voltage level is set at one stage, and then a clock moves the memory forward, in a Bucket Brigade type way. So the voltage level gets handed off to the next stage, and then the next stage, and the next stage, and this goes at a pace that's determined by a clock down the line, and it creates a delay. It's the simple way of explaining it.
It's kind of like an analog shift register.
Exactly. But what you're doing is, rather than storing a bit, just an on and off bit, you've got a voltage level in there. It's usually very small. It's a low voltage level, but because it has this analog range that you can put in an analog audio signal and put it through the delay line, and it'll chops up the signal, puts it through the delay line, and then you have to filter it and sort of smooth it out a little bit on the other end. And so, but they were revolutionary for their time. And if you had enough Bucket Brigade chips and enough going with a fast enough clock, you could get some decent fidelity. But to get the really high fidelity, like for studio gear, you had to have like lots of even the longest Bucket Brigade chips, because you had to run the timing very fast. But effects pedals, like the Memory Man and such, they tended to have just a small number of chips, and so the clocks didn't run quite that fast. And so the fidelity is, it's medium fidelity.
It's perfectly fine for live performance.
Perfectly fine for live. Yeah, you get some distortion in there and some, overdrive, and no one can tell the difference.
Okay, so we did the time domain effects, we did the distortion effects. What other effects?
Well, there are compressors, which compress the dynamic range of an audio signal.
Yes,
much like what they use in radio.
I'm familiar with compressor microphones.
Nope.
Well, not that we use
condenser microphone.
Oh man, I always get that wrong. Okay.
Yeah.
Compressors reduce the dynamic range.
Yes.
Right.
Condensers increase the dynamic range.
No, it's just a type of
I'm
microphone.
Totally cooking.
Just throw a condenser out of your mind. It's not important.
Yeah. Okay. Sorry.
That's all right. No, yeah, a compressor, it takes a live signal. Like if you take a microphone, you plug it into an amplifier, you have the microphone's going to try to reproduce the dynamic range of your voice from the quietest to the loudest. You've got this peaking, spiking, very widely swinging audio signal. And what a compressor does is it takes that very widely dynamic signal and it begins to limit it. So it brings up the noise floor and it begins to squash down the headroom without distorting the signal to decrease the dynamic range. So the actual amount of swing, the variation in the actual strength of the signal becomes more limited.
And that makes the whole thing sound louder overall. I mean, it isn't really, but it makes it sound louder.
Right. And it increases the perceived loudness quite a lot. And it also removes the percussiveness. So you don't have the loud hits, the loud, peaks. So it homogenizes the sound, but at the same time, the perception of loudness increases, which is why it's being used in radio since, like the 30s or 40s.
Well, and it got really bad in the 80s, and that's why it gives me a headache. But that's all whininess, unless you want to talk about Rush, in which case we can talk about Rush.
What?
Didn't they overcompress one of their CDs such that they had to re-release it recently because
yes, they did.
Was that a Rush? I know that the Metallica.
Yes, that was even worse. Yeah.
Yes, Metallica has the record for the most compressed CD. Well, CDs today, CDs I think have more compression than like they ever used on radio. It's compression on CDs is to the point of ridiculousness now.
It's gotten better. The loudness war has started to ebb a bit as better engineers have started paying attention.
It's funny because when people come over to my shop, especially younger people who have grown up listening to CDs and MP3s, and I play them a 1950s hi-fi record on my hi-fi vinyl through a all-tube hi-fi. And they hear the immense dynamic range. They're really taken aback because they never heard anything that lifelike coming out of a CD. And I have to explain to them, well, it's called dynamic range, and they'll say, is it supposed to get that quiet? Why is it so quiet now? It's like, well, that's it's really quiet.
It's funny if you go back and listen to CDs from the early days of CDs, the 80s.
Yeah,
they have much wider dynamic range than anything from the 90s or the early 2000s.
Well, to a fault. Actually, using Rush as an example, I think one of the first CDs I bought was a Rush CD, and if you look at it on the meter, I mean they have like it's 16 bits, right?
Yeah.
So like peak level on the CD is like 8 bits. Like they're only using like half of the total dynamic range for their peaks.
And we all know what 8-bit music sounds like.
Well, exactly. Well,
it's not the same.
Yeah. Problem is that the early CDs, they were thinking that they would keep it really quiet, but the problem is the majority of the music is down in the 4, 5, 6-bit level where you lose all the fidelity, which the low sampling rate is bad enough, and then you take into that the fact that you're only using the bottom bits, and then you really don't have much left.
And then they switch just using the top bits.
Exactly. It's from one extreme to the other. I know that there's a White Stripes CD I have where if I play it, and I have analog meters on my preamp, and play it through the CD player, and the meters go to 0 dB and they don't move.
Right.
Like the music you're hearing drums, you're hearing guitar, you're hearing vocal, but the needles just staying stationary. It's just 100% compression, no dynamic range at all. So. It's amazing that you can actually get sound waves coming out from that kind of compression, but they've definitely gone as far as they can go with audio compression these days.
Well, then I really do think they're coming back. Some of the newer CDs we've gotten are better.
Yeah, I know of a couple of producers and engineers who are working very hard to.
And I know they discuss it more.
Range. Yeah. But it depends on the genre.
And the indie
stuff that ends up on the radio, typically they try to compress because they want to be the loudest thing. And then the FM radio, of course, recompresses everything to match levels. So it's,
This is why you refuse to listen to the radio, isn't it?
I don't listen to music on the radio.
Oh, well.
Yeah.
We all know I'll listen
terrible.
to anything.
It sounds terrible.
Well, I spent a lot of years in radio, and I do have a fetish for FM compression, and especially I do like to listen to certain kinds of music compressed, particularly 60s music, because that's the way I always heard it, on the AM radio. And for certain kinds of music, I do like the AM radio sound and the FM and the 70s FM radio sound for certain kinds of music, because that's how emotionally that's how I remember hearing it. But there's also in the other extreme for the new sort of war on fidelity is the Neil Young product. He's got this new company, or is part owner of a new company that have come out with this new digital recorder. It's a very high band digital recorder to bring back vinyl level fidelity in a digital arena. So there are some new lights on the frontier of fidelity in that respect.
So that leads me to a question about pedals. Back to pedals.
All right.
Unless you wanted to ask it. No. Okay. So talking to my brother, the brother-in-law that was
his brother, my brother-in-law.
Yeah.
It's amazing how this works.
Hi, everybody.
Did we mention we're moving and we're a little tired? Okay.
He has a lot of effects pedals, and he's bought a lot of effect pedals in the past. He has a lot of amps, guitars. He has a lot of everything, and so he has
every
some
time I
understanding.
remember an amp, it's one that he's sold. Like,
Well, that doesn't
how is that
happen at all.
Marshall you got? You were so excited about it.
Oh,
and
he
then
hasn't
it's
played
gone.
Marshalls in decades.
I know. I can't keep up.
We're off track.
Okay, sorry.
But what he says is a lot of the sound from these pedals comes from almost particular components, like
The JRC 4.
There you go.
4558D. Yeah, JRC 4558D.
Is that an op amp?
4558 is an op amp, yes.
So I guess my question is, I have no knowledge of the electronics of these things. What is it about a particular part?
Why can't you just go to DigiKey and, type in op amp?
Yeah, and this may be a little bit of devil's advocate asking the question, because I sort of understand, but
why pick one part over another?
Right, yeah.
Well,
it's a different thing than when you're building a digital circuit, right?
It depends. It depends on what your goals are. I use a variety of different kinds of op amps, transistors, different components, depending on the specific design and depending on what it needs to do. Op amps, there are several different things you'd look for in choosing one. One is the voltage range, supply voltage. So certain op amps work better at low voltages, like if you're working off a 9-volt battery. Some work better at higher supplies, like 18, 20 volts or so, dual supply, like plus or minus 9, plus or minus 10 volts. So there's a voltage range to consider. There's also signal to noise ratio. 4558 is a kind of a very basic op amp. It's not really the quietest thing in the world, The 741 is another one. It's kind of ubiquitous, but it's not really that quiet. There's also the output range, what percentage of the supply voltage can you get as maximum output, without clipping. And so some op amps are designed to be what they call rail to rail, which means that the output of the op amp will go, to the supply voltage and down to ground nearly, so whatever the supply voltage is, you could get an output signal of that same peak range. Most op amps, there is a limitation, some limitation of the output, what kind of maximum output you can get based on the supply voltage. And there's, there's also, some are CMOS, some are JFET, they're FET based rather than having transistors in there. There's lots of different choices and different applications, and also current. Current can be an issue if you're, depending on what you're driving. So, all those things you take into consideration in the components that you're choosing in an op amp and what it's supposed to do.
Do some of those things affect sound in ways that nobody else would care about otherwise designing a circuit?
Basically, the only thing that the user would really notice is noise.
Okay.
The noise. But everything else is really based on just the kind of engineering that you're trying to, the kind of role that you're trying to get the op amp to play, as far as the kind of, like I said, the kind of dynamic range that you need out of it, the kind of current output you need, the kind of signal to noise ratio you need, and the kind of supply voltage that you're going to have are usually the main considerations. And of course, there's also cost, because the different op amps come in different. Usually, there's several choices, that they'll give you, and the choices usually end up in some sort of a letter, or combination of letter designations at the end of the op amp that designate tolerance, like either manufacturing tolerance or temperature range, or other things that would make an op amp that's identical to another op amp like much more expensive or much cheaper, just because there are certain qualities of that op amp that have been changed or tightened depending on the type.
Matthew said something about slew rate being important with that particular op amp, the JRC 4558D.
4558. Well, I don't have the data sheet in front of me, so I wouldn't be able to answer any specific questions. But
you mentioned a lot of other characteristics, and
right.
I wondered if slew rate was an important thing. I shouldn't make fun of my brother-in-law. He might listen to this, but occasionally he tells me things about electronics, and then I go off and think about them and think, no. But is this one of those things? It's true. Your father listens to this sometimes too. I'm gonna have the worst Christmas.
Yeah, if you look at a data sheet for any op amp, you're going to find quite a lot of data about its performance in every conceivable type of application. So, depending on what you're looking for, you would scrounge for those particular features for a particular component. So slew rate might be a consideration in a particular kind of design. So sure.
Why the old op amps? Why aren't there new op amps that meet all of these criteria? Why do people get so attached to the sound of a particular op amp that was only made in the 70s or whatnot?
I don't know if people are necessarily fond of a particular op amp sound, but they've stopped manufacturing and developing analog chips quite some time ago. It's just I'm not aware of any new classes of analog amplifiers being developed or that have it's not a frontier. In fact, most analog chips have ceased production. Like the bucket brigade chips that I talked about. Most signal generators, a lot of the original analog chips have all ceased to be manufactured, or are now being manufactured only in a cloned format, maybe a substandard format. So, but the ones that you talk about, like the 4558, like I said, the 751, these are very, very old types. So they're just ubiquitous. They're just standards, really. So they're just much easier to obtain. And there's something to be said if you're doing manufacturing to use components that are readily available or still available, as opposed to using components that are antiquated or no longer manufactured. So
I think there's some folks who get a distortion pedal or something, and then they, a newer model, and they will try to replace the circuit with something from, a more vintage circuit to try to replicate that sound, and maybe not without any particular knowledge of why that works. Just, it used to have this op amp, so I'm going to swap this out. So there's some of that happening, I think, too.
Yeah. Well, I'd people like to do stuff like that. I'm not sure that really makes a difference tonally. I mean, because the op amp isn't really going to be giving you tone. And that's all in the support stuff. The capacitors that you're using to buffer your stages. Filtering,
Okay.
other things affect tone. The performance of an op amp, if it's just amplifying a signal, is pretty straightforward. You're not really getting tone out of it necessarily. I mean, the only thing that, like I said, swapping out op amps is really the only thing that's beneficial is if you're choosing a lower noise version
Sure.
over one that's noisy for a high gain stage. But other than that, there's really little or no benefit, I think, to backwinding an op amp. But I have this discussion a lot with people who want to argue the idea of mojo, and I. So that's this is where it gets to the subjective nature of music and sound. Where it becomes less scientific and more about if you believe that it sounds different, then you hear that it is sounding different. Does that make sense?
Yes, totally.
Oh, totally.
Yes.
This is where we talk about gold cables. But
And my brother's
Yes.
going to kill me, but I have an example of this.
did you send him the same song twice?
Yes. Years ago when I was mixing one of our records, I'd gotten a little bit irritated with the number of slight changes in track levels and
Tweaks.
things. So I claimed I had made one and showed it to him. He said, "Oh, that's much better." And of course I had done nothing.
Well,
He was very mad once I revealed to him that I had done nothing.
and Fran said she liked the way FM and AM sounded
Oh,
for
yeah.
some types of music. And so some things are very subjective but real. And it's like smell. Like, I don't like the smell of bananas. That has to do with a childhood trip in Mexico and a banana that was left too long. It was horrible. So I don't like the smell of bananas in a way that's very visceral. But if you listen to music on FM, you start liking the way FM compression is. And so music is like smell in that it's not something you process intellectually. It's something you
I think
care about.
talking about music quantitatively is probably not going to lead anywhere that makes anybody happy.
That's true.
Except if you're a digital designer.
Right. But like the arguments over tube amplifiers versus solid state versus vinyl versus CD, everybody is associated with
I can make
their
those arguments all day.
Oh, sure.
Yeah.
But there's also a lot of nostalgia attached to that stuff.
Yes, but there are. I mean, it's pretty broad, but I mean, there are very clear sonic distinctions between like a high fidelity tube amplifier and even a high fidelity solid state amplifier, just in the way that they reproduce sound.
Oh yeah, no, I'm not saying that they don't.
Different dynamics involved, and also even between CD and vinyl. I mean, there's just no contest about fidelity. It's just there's just so much more information on even the worst vinyl record as opposed to even the best CD. But
whichever you like is more likely to be whatever you
grew
like,
up with,
or whatever you grew up with. It's less likely to be what is the highest fidelity to life.
I still have fond memories of cassette tapes, which I think everyone can agree were terrible.
Yeah, well,
I had that one that was sort of melted.
Let's say 8-track, pretty awesome. I still have 8-tracks that I listen to.
Those are nice wide tapes that. Yeah,
moving much faster tape speed, much wider tape path. It's just more tape moving faster equals more fidelity. That's just the reality. So, but yeah, and micro cassette. Well, forget it.
But I can see how people get very passionate about what they believe in music, whether it's.
And it's complicated though because there is truth and belief, and it's all mixed together.
Yes. And right and wrong don't.
I mean, guitar amplifiers is one area where, yes, they have solid state modeling amplifiers that are supposed to sound like tube amplifiers, but they just don't. And so you get people like, why are you using this old thing from the 50s with, tubes from Russia? Well, this is why. And then you hear somebody play through it.
Well, a tube amp, it's all about the transformers.
Yeah.
So that's what you don't get in a solid state amp. Is solids. I mean, the fundamental difference is that solid state amps are direct coupled. Transistors directly drive the speakers, and with a tube amp, you've got a big iron transformer in there, and that big iron transformer that gives you all the tone. It's just it's really where it's all at, is a transformer.
Could you define tone?
Harmonics.
Come on, the time I asked Matthew for that, it was awesome.
Defining tone is like defining tone is like describing smell.
That's fair. That was not the answer Matthew gave. It took an hour. It was hilarious. I wish I'd recorded that. Oh, okay. I should stop looking at Matthew's email. So let's see. Okay, so this does come all back to why can't we do it in software? I mean, I understand that some digital electronics and that not everything is perfect.
No, the problem is that it's too perfect.
Oh, is that the problem?
That's my understanding.
Okay.
Well, it's not that that things can't be done virtually or emulated. It's just a matter of why emulate the world when the world is so great is my argument. The art of analog electronics is dealing with the real world of physics. It's not about having a repeatable algorithm or emulating the world or a virtual tone. It's about the real world. It's like my telephone. I've got an old Bell telephone with carbon receiver that I like to use, and I hate my cell phone just because there's something visceral and real about a phone that has weight to it, that has a sound to it, that has real analog qualities to it, and so I think that for younger people, it's definitely a generational thing. I think because younger people who grew up with the idea that everything can be emulated, that everything can be virtual, are quite happy with that. And I think that the distinction between why analog audio as opposed to digital processing, you're going to find the lines are pretty divided about personal philosophy and really and the personal experience of music. For me, music is a living, breathing thing. It's human beings, it's instruments, it's the human voice, it's human hands creating live music and recording music in an analog format, processing it in an analog way, playing through analog effects through an amplifier. There's no substitute for that in some ways. So some things like delays and things like that, arguably, it's better to do it in a really good digital way than to try to do it with the older Bucker Brigade technology for the reasons I previously expressed. But other things, it's you can tell, the difference between something that's got a visceral, living quality to it and something that's emulated. And it might be like you said, that it's too that a virtual effect might be too perfect or too perfectly repeatable, not really wild enough, maybe.
Yeah, one of the things I do a lot of recording, and one of the things I try to do is, like you're saying, emulate the analog sound, because I can't go out and buy a bunch of vintage gear. It would cost me tens of thousands of dollars to get some of the things that for a couple of $100 I can get a plug-in and attempt to capture some of that in a recording. It's very hard these days to record in an analog way. It's very easy to get a very quality studio built out of digital components. So the tension of trying to get a more live analog sound out of all of that stuff has actually created an entire industry. But those plugins are only as good as your model of a piece of analog hardware. And as you were saying, Elecia, why don't you just have a transfer function but you have to find it.
I said that before we started, actually.
Yeah.
So
you have to find the transfer function from the input to the output, and you might not. It might be hot this day, and that changed the transfer function. It might be this capacitor over here is just about failing and sounds really cool. So it's very hard to emulate all of that. You can get close, and in a multi-track recording, maybe you've got that in a bunch of places, and it's good enough. But I think it's still hard.
So I know I brought up transfer functions before we started recording, but since you brought them up on the show,
You're going to ask me to define it?
I am.
Oh, wow! It's been a long time since that class.
So a transfer function is usually used in systems engineering, is what the class name, in case you wondered. And it's a way of modeling the outputs of a system based on the inputs of the system. And usually you take it into the Fourier space, and then you can start talking about how the transfer function behaves with signals.
So you say, this input frequency has this happen to it on the output.
Well, for example, the tremolo pedal effect.
Yeah.
You take your input signal of the guitar notes, the tones of the guitar, and then you add it to a sine wave. And that gives you the wah-wah-ish addition to your sound.
Right.
And if you did that in the frequency domain, the addition actually is not that interesting. But if you multiplied it, then it would be really cool. But I guess then you would end up with something more echoey.
Yeah. So I guess what I'm saying is you can do that, and you can try to take an old piece of electronics and figure out.
And it's easy to do sine waves.
Yeah.
But it's really hard to build a room.
And it's really hard to build something that's not quite right.
Or not quite repeatable.
Yeah.
For example, if you had a capacitor that was on the edge, you would be playing for a little while, and then it would get hot, and it would do something different.
Yeah.
And then you would not play, and so the first half of your song would be different from the second half, or it would depend on what key you were in, or what the refrain was. And so your components, your transfer function changes with time, which is not a very nice thing to do to your mathematics software modeling system.
Anyway, back
right,
to Fran.
Right, back to Fran.
I think we agree with you.
But no,
I agree with you anyway.
yeah, and we call that modulation. If you're modulating a signal,
right,
like the tremolo, modulating one signal onto another signal. But one of the things about the human experience of sound is that they have found that human hearing is in the animal kingdom pretty bad. I mean, our hearing by cat standards is pathetic.
And mine used to be a lot better.
But
drums.
What really makes the experience of hearing for human beings is that our brains have a superior ability to process sound. And so the way we experience real life, and this is where it comes down to fidelity. What is fidelity? Experience of fidelity in the human mind is all about time, because in our stereoscopic world, our ability to discern time between our two ears is phenomenally fast. So it comes down to when you're trying to let's say that you, like you say, to emulate a room, the sound of a room. If you're in an empty room and you clap your hands and you hear that sound, or you record that sound, but clap your hands again. Clap your hands 100 times. Every time that you clap your hands, that sound that's recorded is different. It's never the same twice, because you're never applying the same amount of force. Your hands aren't meeting in exactly the same way. You're moving around. Maybe you move your hands a little bit to the left, to the right. You're breathing. The air is moving in the room. There's this immensely complex system which boils down to every single atom in the room and the atoms that make up the room itself, the temperature, all of these things, the butterfly effect. You got massively dynamic systems that are determining the specific sound of that room for that sound that you're creating at any one time. And so, what is the point of modeling a system that complex when you can just actually record clapping in a room? And that's sort of that would be my argument about analog versus digital.
Yeah. Sometimes the only reason is you don't have a room.
Yeah.
Well, that's just sad not to have a room.
It is true.
Well, I'm never going to sing in a cathedral, but I can pretend.
Well, it just so happens, one of the things that I'm going to vlog about is my plate reverb, which is it's the ultimate analog way of emulating a cathedral. So hopefully I'll be able to do a demonstration of that.
Well, wait a minute. You just said you should go to the room. Now you're emulating it.
But she's emulating with analog.
Yes, I'm analog.
It cancels out.
It's emulating stuff.
I'm emulating it in a with a device that has its own extremely complex system. It's its own complex environment in a real plate reverb. So, in a sense, it is sort of it's a room in a box.
That is cool. Although my software is really complicated too.
Yeah, but it's deterministic.
Yes, the deterministic is part of the problem. And now that I've looked up tremulos, I realize that it is modulated, which means it's multiplied, which means the Fourier domain is interesting, and yet we're still going to go on.
Okay.
Because adding a sine wave would just add a
offset.
A squeak.
Oh.
It would just be a
tone.
A tone. Yeah. Okay. Sorry. I have to look up the effects pedals as we talk. I'm so clueless about this. It's pretty hilarious. My brother-in-law plays rockabilly. What
he does?
He used to. He plays rock. What does he play? I don't know. We haven't been to see his new band. We're horrible people.
They play rock and roll.
Okay.
Rock and roll, rockabilly, it's all good.
What pedal should I be looking at to give him for Christmas if this is the amount of information I have?
Well, if he's playing rockabilly, you don't want to buy him a pedal. You want to buy him a really good amp.
He's got those. No,
amps are expensive.
So to give the history better, our band, he and I used to be in a band, and we played originals that were very 60s tinged.
Oh, you played Wipeout, and there were a couple of songs.
A lot of surf stuff.
They didn't sound like Wipeout, but definitely were in the same family.
Surf and blues and things of that nature.
Yeah.
So he had a few pedals he played through, but I don't remember what they are. No, I should have had him send a picture of his pedal board. Anyway.
Well, one of the things he said about his pedal board was that most of the pedals change the sound even when they're nominally off or not engaged. Does that sound right, Fran?
Depends.
I think that's called true bypass or something like that.
The bypass mode. Well, some pedals are true bypass, meaning that you've got a switch, a mechanical switch, which is turning the loop of the effect in and out of your signal chain. And the true bypass, when the effect is off, the effect is completely taken out of the audio chain. It's just there's a hard switch. Some pedals are on all the time, and you're basically just playing through. You're always playing through the electronics, but it is just electronically switching the effect part in and out of the audio chain. But you're always going through transistors or op amps or something. It's always on. Those are two different kinds of.
And even if you have like a knob that controls a potentiometer that signals the amount of that effect, even if it's already all the way to zero, there's still effect.
In like an active switched effect, you're only when you hit the pedal button to switch it on and off. You're only switching in and out the effect itself, but you're still playing through some electronics in the pedal with active switching.
So you're going to get the noise and other things that might be not desirable.
It affects the signal because the main issue is the dynamic range. It's not the same as having the signal just go right through. There's a guitar signal is very dynamic. So as soon as you start putting it through a transistor that's got, or even a series of transistors, that you're almost inevitably dropping the dynamic range a little bit, just because you're going through some circuitry that some people can hear as a slight loss in fidelity. Some people can't. It also depends on if you're really looking for a really, really clean signal, or if you're, if it's really dirty, you probably can't tell.
Right.
But that's usually the reason for true bypasses. And the other reason is, pedal boards, because there are some players that they're not playing one pedal or two; they've got 20 or 50 effects. And if some of them or all of them are actively switched, well,
yeah, just got a mess.
Be bad. Yeah, it's all sorts of bad.
Yeah. So that's the other argument for true bypass, is if you've got lots of pedals, the signal will get muddied very quickly if you're going through 15 amplifiers on the way to your amp.
Even if those amplifiers aren't doing,
even if they're very good,
yeah.
Even if they're very good and very clean, but you get loss, and whenever you just keep adding stages.
That makes sense. I feel that way about software. If someone wanted to build their own pedal, a do-it-yourself sort of thing, maybe for their brother-in-law, what advice would you have for them?
Learn to solder.
Okay. Most of our audience, if they don't know how to solder, it's on their list to learn. So yeah.
Okay. So solder, check. Well, there's a lot you can learn online. I mean, there's lots of projects, lots of tutorials for basic stuff. So, it's like any other electronics project. You got the same challenges with construction, and you're going to put it in a case, and you're talking about a high gain type of thing with subject to hum and radio noise and stuff. So with the pedal, you're going to take more time and consideration for your case and your grounding and trying to keep noise out and such. And but it's the same challenges as any kind of electronics if you're building your own pedal. So,
well, I do a fair amount of digital stuff, or putting together different dev kits from Adafruit or SparkFun or any of the evil mad scientists, and so soldering. Yeah, I do a fair amount of soldering, but the analog stuff I just look at and go, "Where's my data sheet for the digital, for the ADC?" I don't even. Yeah, op amps. I know what they are. I could design them, but I don't really know how to use them. Do I need to learn how to use op amps in order to be able to make my own guitar pedal?
Not to make it, but I mean, I guess the difference would be if you're going to make a pedal based on an existing design, or if you're going to design a pedal as like a new concept. Now, if you're going to design it from the ground up thing, you would have to understand some basics about op amps, just to be able to control them, control their gain, deal with noise, have the right kind of feedback, have the right offset voltage and such. But if you're just working off of a schematic, like if you have a design that you're just going to build, you don't necessarily have to understand the specific components to be able to build it.
Right.
And
I think if you were to design or invent one from scratch, I think knowledge of how op amps work, and then knowledge of basic RLC filtering.
Yeah, sure. Filters are a little more advanced, but you can certainly do well with some basic knowledge about all analog electronics. Not just op amps, transistors, feedback, biasing, RC filters. So yes.
Sounds like building a guitar pedal would be a good way to learn about some of these analog electronic concept.
Oh yeah, sure. In fact, I think, especially for young people, young people are starting out and they're playing guitar. A pedal might be the first thing they want to tinker together. So yeah, it's and there's certainly the reward factor. Because whenever you do a project, you want to have the reward of of completing a project that does something for you. Even if that's just the satisfaction of looking at a blinking LED. That might be a goal. But certainly a guitar pedal has the motivation of that. If you're successful, if you build this pedal, but you're going to play it, and then you can, show it off, and it serves a rewarding purpose. So it's a good motivator for a project, I think.
It's part of your own musical identity too. It's not like just, it's something you use as a tool. It's, making your own tools is differently satisfying than making something that you play with
And if you build it, you can fix it.
Right, that's true too.
Well, conceivably.
Yes.
Yeah, troubleshooting is a whole other art that people should learn, troubleshooting. But, when you do a project, there's always troubleshooting involved. So I think learning troubleshooting goes hand in hand with building.
So after we finish the show, I'll ask you for some links for do-it-yourself guitar pedals, and maybe we'll find some good suggestions in case people want to build one or two. But I'm not. I should have warned you about that question ahead of time. You sell guitar pedals though, in case people don't want to build their own, and that's Frantone, frantone.com.
Correct.
How long have you been doing it?
21 years.
But you took a break in the middle.
Took a break. Well, it took a couple of breaks, a few breaks actually. I took a break in the 90s when after I came out with the Peach Fuzz. It was like a year after I came out with the Peach Fuzz. I really got burned out building pedals. It was, I had a 2-product business, and I just got tired of building. And I took up a job working for my competition, and moved to New York and worked for Electro Harmonics for a couple years. Then I went back to doing Frantone full-time in 2001, and then ended up stopping production again in 2009. So I've been on hiatus for 6 years, and bringing it back, not because I'm not, rather than doing the manufacturing myself, which I don't want to do anymore. I've licensed out the manufacturing to another company, and they're actually doing the manufacturing. I'm just doing the designing. So it's much more, much less stressful
Yeah.
for me not to have to deal with the manufacturing.
Cool. When do you think they're going to start shipping?
Well, soon, I hope. It's been in the works for quite some time. So anytime, really. Anytime now.
Well, I do wish you much luck getting it actually shipped. Christopher, any additional questions?
Probably thousands. Probably could talk about this for hours. So
Yes, but we have to pack up this stuff today.
Right.
These microphones don't jump into a box on their own.
We didn't get the good ones.
The good microphones?
The ones that jump into boxes on their own.
That would be cool. Fran, do you have any last thoughts you'd like to leave us with?
Yeah, it's when you're having an asthma attack, it's always problematic to do a podcast. But hopefully we can edit out the coughing and the yeah. Well, I guess part of that analog tone discussion is that nothing gives you tone like asthma.
That sounds like an advertisement for something.
Sounds like a new name for a pedal.
It's asthma, the effects pedal for your chest.
My guest has been Fran Blanche of Frantone. Check out her YouTube channel and her pedal page on frantone.com. Of course, there'll be a link in the show notes. Thank you very much for joining us, Fran. I hope your breathing gets a little easier.
Thanks for having me. And like the weather, this shall pass.
And thank you, Christopher, for producing and co-hosting. And thank you to Matthew for not ever listening to the show. For the rest of you, thank you for listening. And thank you for our new iTunes reviews. We really do appreciate those. If you'd like to say hello or, send us feedback in case there's something you didn't like, hit the contact link on Embedded FM or email show@embedded.fm. As we alluded to, Christopher and I are moving houses. That shouldn't impact the podcast too much, but it does mean we'll be a little distracted in the next week or two. If I don't get back to your email, feel free to send it again. Sorry. My final thought for this week should be something profound about houses, but instead I found something by Buckminster Fuller because he's so cool. You never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete.